So next up, we have HUASUN Energy's Head of Business Development for Europe, Christian Combs. Today, Christian will shed light on heterojunction technology growing from niche to mainstream by 2030. Welcome, Christian.
Thank you, Anu, and everybody. Hello. I'm going to give a lot of information that is not exactly in line with what Molly has explained. So let's see how the presentation goes. And I think it's good to have different views so that we get more context. You know what they say, information without context is propaganda. So I will try to give as much context as possible today so that we get actually informed. So I think you can see now my screen. Let's go on. The first context information I want to give you is related to the past. We're going to 2005. That's the year I started doing photovoltaic, and I already started with heterojunction. So this is quite a big information point I want to give to you. Heterojunction is not the new technology that comes after TOPCon. It's a technology that has been in mass production since 1997, improving slowly or rapidly, depending on how much R&D was put into it. But it has been really on the field for a very, very long time with very good results. At the time, Sanyo, who were the inventors, Panasonic just took over, were leading in efficiency, and they were leading in front of back contact cell. However, this is a point, again, context is very important. Back contact cell is not a technology. Back contact cell is a cell structure. And instead of back contact cell versus heterojunction or versus TOPCon, it's back contact cell versus front and back contacts. Because you can have back contact cell based on many different technologies, including heterojunction, but as well TOPCon or PERT. And this has been changing over the years. SunPower, which today is called Maxion in terms of technology, was chasing heterojunction in efficiency, but you know the numbers. Look at them, they're very low compared to today. If you try to sell a module today with 18% efficiency or 19, you will just not sell anything right on the market. The classic module was just behind. Remember, at the time, production costs were very high, and we were talking about selling prices over €3 per watt or over $3 per watt, really expensive. If we move forward to 2013, that's an important date because it was after the first radical cost drop down. We were already at less than €1 per watt. And at the time, back contact cell was in parity and efficiency or a bit higher than heterojunction. So it looks very much like today, just 3% lower efficiency compared to what we have now. And we had an important point at the time is that bifacial started with heterojunction. In 2007, we already installed some bifacial panels in many places to test. At the time, bifaciality was very low because the solar cells were just the same as the front side with a lot of silver on the back. So bifaciality was like 60%. But it was already known at the time that heterojunction had a natural bifaciality of the cell of about 97% if you do things right. So that was starting to play a role in the thinking of the people. And the gap to BSF was widening. This gap that was bigger and bigger motivated the introduction of PERC into the equation. So now we go to a big jump from 40 gigawatt total market to 2024 with much more than 250 gigawatt total market and prices around, clearly below 13 cents for every technology, maybe not back contact cell, but all the other ones. Now we are jumping over monoPERC that came and went, and TOPCon is now the standard. And you can buy today 700 watt modules of the highest power, maybe 695. And heterojunction, and this is the first information that is maybe contradictory to what has been shown here. In real sales, in heterojunction, you get still 10, 15 watt more than TOPCon for a similar product, bifacial product in the same size. And in back contact cell, I put here what was published by ICO in the exhibition. Obviously, the reality is always a little bit lower, but still it has a gap of efficiency compared to heterojunction right now. It is important to note two things. First, as Molly mentioned, the price or the cost to manufacturing a back contact cell is really very high. And the second is that you need to see apples to apples. And right now, if you want to have a back contact cell with bifaciality, the bifaciality is very low. And the output power in nominal conditions of a bifacial back contact cell is much lower than a monofacial back contact cell. So in reality, the playing field is much more level than this slide. But you see that we're still keeping this idea that back contact cell and heterojunction next to each other, maybe one on top, the other on top, or back contact cell based on standard technology, today TOPCon, and heterojunction based on front and back terminal, are always leading the pack in efficiency, and the lower cost general purpose module is behind, just following the trend. And this is the basis, this is the context in which I want to show you how the next step looks different for heterojunction. And we go to the actual presentation. First, the general view is quite important because heterojunction does not come from nothing. It comes from a very, very long history of application. And this brings knowledge of bifacial, let me just turn on the light so you see my face better. And this brings knowledge about the reliability of the platform that is not available in any new technology that you get. And this is a fundamental difference that every manufacturer who is doing the long-standing technologies, such as heterojunction, will bring to you. And all of those who are innovating but don't have a track record will just not talk about it. And will just show some test reports, which are very nice, but are not the big information source that are the real track record on the field. We as a company are relatively young. We were founded in 2020 based on people in the industry who wanted to do heterojunction instead of TOPCon for the next step of large-scale production. And we have a different view or a different approach compared to most of the high efficiency, I'm talking back contact cell, but heterojunction as well in the industry, because we want to bring heterojunction to large scale. Of course, we sell as well to retail, to small roofs, because the module is very good for that. But we are focusing on utility scale because we know that the LCOE is lower with heterojunction, which is the key point at utility scale. And because of that, we have much more production capacity than everybody else in the field, because we knew that to reduce the cost, one of the key elements was the really big production capacity, so that the capex of the machinery for manufacturing would not be more expensive than in TOPCon options. And this is one key aspect. We have managed to lower the cost of manufacturing to be compatible with TOPCon. And this is quite key, otherwise we would not be doing this. I'm going to just show this slide to show you why this is relevant. We think we find ourselves now in the same pivotal moment that TOPCon versus PERC was 2 or 3 years ago. It is the moment where the manufacturing capacity of heterojunction is still relatively low, and there is a price gap. I remember at the time that we had a 1 to 2 cents manufacturing cost gap, similar to what Molly has been putting out, like 1.5 cents. And TOPCon was more expensive than PERC, but had higher efficiency, and even more important than higher efficiency, had higher bifaciality and lower temperature coefficient, because those two effects become more and more important because they increase the yield compared to just the efficiency. And this is the big game that has to be played together, because when you have a solar module that is less and less expensive, it is now just over 10 cents, where a solar plant costs maybe 50 to 60 cents in total. The performance of the module becomes even more important. So the performance of the module with higher bifaciality, maybe better low-light performance and lower temperature coefficient, creates a value gap. And this value gap that heterojunction has versus TOPCon is very similar to the value gap that TOPCon had versus PERC. And we all see in the curves what happened PERC went down and TOPCon took over. And we think we are in the same position today, Heterojunction versus TOPCon. And this is quite key because the other point is that we need to close the gap in cost. And for us, the projection is that the cost parity of Heterojunction to TOPCon will happen in 2025. Not by chance and not by dumping prices and not by any magic, by a lot of energy involved in research and development. All of these steps, I will not go through them. There are some other presentations I've done in other webinars that you can consult. Just send us an email. Have been step by step increasing the efficiency from those 20% to now we have 26% average efficiency in cell production, in mass production, and reducing the cost. And the latest one, zero busbar. That is a massive, massive improvement in the cost. We are, I think our colleagues from Ryzen will mention it later, at a position where the silver consumption is lower at Heterojunction zero busbar compared to TOPCon. And we all know how important that factor is. We are at a position where the wafer cost of Heterojunction is much lower than TOPCon and will remain that way. Maybe just a little fact, zero busbar is not the same for Heterojunction than TOPCon. We have seen mass production implementation of zero busbar in Heterojunction. We are in mass production since this year, and I think Ryzen as well. In TOPCon, zero busbar is not the same as in Heterojunction because we have in the whole surface of the cell something called TCO, transparent conductive oxide. It's a material that is already conductive. So when we do zero busbar, the ribbon that is connected to the cell is connected electrically to the whole surface of the cell, not just the little fingers, which is the zero busbar solution for TOPCon as of today. So for us in Heterojunction, it's not just a way to reduce the silver, it's a way to improve the connectivity and improve the reliability on the long term. In TOPCon, you need to fight against the reliability concerns of having the ribbon connected to only the fingers instead of a bigger area of the pads in super multi-busbar or the push bar in all the technology steps. Just an aside comment. We can go on that in the questions. This means that Heterojunction is already ready for large scale. We have in China many projects for gigawatts ongoing, and we have in Bulgaria a project that is already being installed many hundreds of megawatts and will continue, and we have many other projects already going on. Why? Because the LCOE for them is lower. In Bulgaria, it was a bit specific due to the topography of the location, due to the mountain system, so Heterojunction was perfect, but now more and more is becoming the perfect solution to get the lowest LCOE in almost all of Europe. This is our portfolio, and I want to mention this because I want to talk about the cell format. We see M10 dying. I've seen in that graph M10 of amount of products, M10 being like in the top. I think that's quite outdated because M10, we had M10. M10 was one of our main products, and we see the customers just not wanting M10 anymore because all of the options that want M10 can use rectangular G10 or whatever you call it, G12R, being better for them. And the reason is not to get a larger wafer to get higher efficiency. That's misguided. The point is for utility scale modules with very high efficiency, when you go to many cells, you have two bad things. First, the voltage of the panel is higher, so you cannot put so many modules in a string, which increases the electrical cost and the tracker cost installation. And the second is you get hotspot danger. In the past, it was like 78 cell was like, you don't want that product. It has hotspots, even if you do everything perfect. And even today with very high efficiency, you look at 72 cells per panel and think, maybe let's go to fewer cells. And that is the reason to go to rectangular, because you have fewer cells in a module with the same power. Look, the standard size is 22 meter, 27.8 length. And you could have that in M10 with 72 cells. But now you see the same size being implemented with 66 cells with 210 millimeter height of the cell well cut into. And this is because you reduce the amount of cells, giving longer strings, and giving less danger of hotspots. So that is very clearly the movement for the narrow panel. Many players don't want the wide panel, which is G12, 1.30 m. Many players want 1.13 m of width. Other players, they don't care. They see good results with 1.30 m. And we look at those two formats as the future. And the intermediate, where the length of the wafer in height is in between, we see that as maybe an intermediate step of people who had some ingot capacity that could not do G12R or something like that. Maybe just a step in between, and they will transition to the larger wafer in the future. With those two wafer sizes, we can cover from the residential, this means the less than 2 square meter module, to some intermediate size for industrial, where you can still fix on the corners and get some good mechanical load, to large scale, where we see the two models, one the narrow, one the longer, for one the wider, for utility scale, where you go on one option or the other. And we think that this is the mainstream of module sizes and wafer sizes for the future. And heterojunction, same as TOPCon, same as back contact cell, can offer all of this without any issue. We saw one trend that I want to mention because I think it's a bit forgotten. The electricity price on the free market for, let's say, summer in between 11 o'clock and 3 o'clock is going to the bottom these days. You see that in countries like Germany or Spain, where there is already renewables up to 50% of the total consumption, and more countries will be there. And we see more and more here the necessity of alternative installation methods. Trackers is one solution, but vertical installation is coming up more and more, because we see this as a very good way to spread the generation of electricity through the day, at the morning and the evening. We have in heterojunction a natural cell bifaciality of 97%, and we have modules with 95% bifaciality already on sales. And these modules are used by some of our partners. You see here from Next to Sun, our very valued partner in Germany and all of Europe, for vertical module installation and installation methods. And they are getting extremely good results. And this is something that is up and coming, and we think is the next big trend. And heterojunction can achieve that with this very high bifaciality. We see back contact cell not just very expensive, and that's quite not so nice, right? To be very expensive. But we see that solar modules that don't have very high bifaciality are probably a dead end in terms of utility scale, because in the future, bifaciality is everything. And I will mention later another reason, but for the moment, I don't say what it is. We are looking into the future into tandem as well. And there is a fundamental advantage of heterojunction when we talk about tandem, is that the implementation in mass production is really simple. We only need to add one machine that we already have, but we'll put perovskites onto the cell structure, one more layer. Of course, there are changes in the in-between layers. It's not everything as simple, otherwise everything would be done already. But the basic cell structure is really very similar to heterojunction. At the same time, you may know that heterojunction needs a very good module isolation from the environment, especially from humidity and as well from ultraviolet light. And we already implement that module isolation from the environment. And that is a key point to have low degradation in perovskite as well. In addition, perovskite will need some improvements in reliability, but we're working on that. We already have some small module sizes of perovskite tandem. We will have at the end of this year an actual module, like in G12 big module size, for starting testing, for improving. And we expect that maybe 2026, we will have the first commercial modules with good reliability. And that is the key point looking into the future. Because let's think on the long term. Back contact cell cannot have a two-terminal tandem module because both terminals are on the rear side. So if you want to do any tandem, you need to innovate 4-terminal, something that is really very difficult to do in manufacturing. So if perovskite tandem manages to overcome the reliability or durability issues they have right now, is durability more than reliability, then you will have a module with heterojunction that will have close to 900 watt in the current G12 size. We're talking about more than 140 watt more than today, with almost the same manufacturing cost piece by piece. And if we are very generous and we give the best of current back contact cell 30 watt more, and we don't know where that's coming from because back contact cell is already implemented all of the top possible improvements that we can see. Let's say they can improve 30 watt more. They are below 700 watt on that. And because they are implementing right now only the small size, but they would be below 800 watt. And if we go to classic TopCon, let's say they have more room for improvement and they improve 50 watt compared to today's best, they go to well below 800 watt at a cost that would be higher than this tandem module. How is that going to work for customers? We don't think that that would work. And that's why we think that the path moving forward is actually heterojunction, because TopCon tandem with perovskite is much more difficult. Because of that, we see as well some of the key players on the market. You all know the names, you've heard them. One comes right away, moving in this direction for utility scale. In the next years, heterojunction will have a very competitive proposition, lower LCOE, matching or maybe slightly higher purchasing costs compared to TopCon, higher bifaciality. So there will be a healthy competition. We think heterojunction will be leading, but it will be a good fight. But the moment that tandem perovskite arrives to the market with good durability of the module, it is maybe game over for the technologies that cannot apply two-terminal tandem perovskite to them. And that is the game. And we will see how it goes in the next time, but it's going to be very interesting. Thank you very much for the time, and I give it back to you.
Thank you, Christian. That was a very, very detailed presentation on HJT and its future prospects. Just probably one question, that what about the advantage of like this, TopCon has this massive ecosystem already existing. How will this have an impact on the final costs of HJT, and how would you tackle this?
That's a really good question. So the ecosystem plays a role in two ways. The first one is that you have this, I'm going to call it the dying song of PERC. You have many players who have a lot of machinery installed, and if they're not competitive, they're going to dump the product into the market just because they want some cash flow until they close down. Yeah, that's not nice for the market, but I don't know what's going to happen about that. Then you have the machinery manufacturers. They are they're doing gigawatt. What do I say? They're doing hundreds of gigawatts of machinery selling to these producers, and they're very well organized, and they can reduce the cost even a bit more. We see the natural difference of cost based on LCOE from TopCon to heterojunction between 1 and 2 cents, depending on the region. Northern regions, maybe 1 cent. Because they don't use bifaciality so much, because the efficiency gap is small, because the temperature coefficient doesn't play such a big role. But in the southern countries, in the Sunbelt, in India, in the south of Europe, in Japan, in China, is about 2 cents gap. And the manufacturing cost is well below 1 cent difference today. It will not widen more than that ever, is my prediction. So I don't know what's going to happen to TopCon production, but I see many of the biggest TopCon players will ramp up heterojunction more and more to have a second leg to stand.
All right, interesting to know. So I guess there are more questions in the chat. So if you can please...
I will go there until the panel starts.
Yes. Thank you so much.
Thank you.